Are we live yet?
Alright, so where do I go now? Home? Live?
And then, Matt's page.
Yeah, we're live.
Okay, thank you.
You got it. We are back in business.
Alright. It's not doing anything for me.
It takes just a minute to catch up.
I need to hit the kiddo sign in.
So just have them go to my channel, and it'll pop up there.
Doing it now.
Well, I'm looking at your channel.
Refresh it.
I don't know why it takes.
That you see, okay? What you say? This one. Okay, so put it up. Okay, they match. Go.
So close out of YouTube.
Do we need to zoom in? You think you will?
Where my imagination goes.
No. Well, maybe just a little bit. We got people in.
There's 2 in there. Do you want me to put on there? Make sure you type your name and.
Yeah. Tell them to log in.
Whose is this? You and just you?
Me and Listerman. Listerman and I.
It's not coming up. It's, but the live feed's not coming up.
It takes a little bit.
Yeah, there's 15 students on there. So I don't know why yours is.
Are they any of my kids?
I didn't tell them to sign in just yet, but they're gonna. I mean, there's 20.
Why don't you go ahead and say hi and all that good stuff and tell them.
Hi, everybody. If you're online right now, go ahead and type your name in the chat and which teacher you have, so we can have a little record of attendance. I know that we're having a little bit of technical difficulties getting things fired up here this afternoon, so just bear with us for another minute or 2.
Yeah, so there we go. Hudson Armstrong, Cameron Myers. Yeah, yours are in there. It should be good up there. That's what they're seeing.
That's what they're seeing. Mr. Winter, we good to get started?
How many do we have? We have about 20. We should go ahead and go. How many do we have here?
30.
We got 22.
So we should have about 40. So whenever we get about 30 people, we can go.
Yeah.
35 total.
35. All right. Well, welcome to week 2. I know that you guys have had a lot of challenges, and we're going to get started with the bio stuff this week, and we're going to get down to talking about measurements, especially using the metric system. In science, I know that you guys have been exposed to the metric system several different times. We're going to go through what we're going to use for biology. We're also going to use talk about conversion from one set of systems of units to another. So the metric system is also known as the SI system. Give you a little bit of history. It was developed by the French in the 1700s. It was a way of creating a unified system of measurements. It's also based on the powers of 10, which makes converting from one set of units to another very easily. And it is used by almost every country in the world except ourselves, because we're America, we do what we want, and nobody else follows that system. Unfortunately for us, though, converting units becomes much more difficult. Think about it when somebody says how many feet are in a mile, or how many yards are in a rod. And if you measure volume, solid volume, you may not even know that there's a such thing as a cord, which if you burn firewood, you know exactly how much a cord is. So the SI system allows us to have unified units, allows us to have easy measurements, and to convert from one thing to the other. Scientists use this as a way to communicate. It's abbreviated the SI, which is French for Système International. So that's why it is known as the SI system. Prefixes that you should be familiar with, regardless of the unit. So whether we're talking about grams, meters, liters, the prefixes all represent the same number of units. Okay, and you should be familiar with some of them, such as kilo is 1,000. All right, centi is 1/100th, and milli is 1/1000th. Those are the most common ones that we use when we measure. All right, those of you that are video gamers, you know all about the games that say 2K12, 2K20, 2K21. The K actually represents 1,000. That's where it comes from. Centi, if you think about words that begin with cent, such as century, there's 100 years in a century. A penny is worth a cent. All right, that's worth 1/100th of a dollar. Actually, the Roman armies were organized into groups of 100. That's where the name centurions comes from, 1 of 100. And milli is 1 of 1,000. So those are the ones that we're going to use most commonly in science class. All right, so 1 meter is equal to 100 centimeters, which is equal to 1,000 millimeters. And we're going to talk about when it's appropriate to use which prefix.
Okay. Just go over this a little bit. Yeah, there you go.
All right, this is one of my favorite monikers to remember the different levels of the prefixes. Many kids have dropped over dead converting metrics. For those of you that like to change from one set to the other, which we'll get to some practice later. M for mega, which is 1 times 10 to the 6th, or a million. We won't use that very often. You'll see that in more of like computers when they talk about megabytes. That's 1,000,000 bytes of information that they do. K for kilo, that's 1,000, which we have done. Hecto and deca are 10 and 100, or 110 respectively. Over is just a basic unit. Okay, so there's whatever without the prefix. That's our liter, that's our meter, that's our gram. Dead is deci, which is 1/10. All right, centi is 1/100th, and milli is 1/1000th. And then there are some smaller ones that even go beyond that, micro and nano. So if you've ever heard the term of nanometers or microseconds, you're talking about 1/1,000,000th or 1/1,000,000,000th of a piece. All right, let's talk about length here. How do we measure length? We're going to use it's the distance between 2 points. Right? The SI base unit is a meter. Okay. Typically, we use feet in America. In science and in using the SI system, we're going to use meters. And a meter is roughly about 3 feet. All right? We're going to use the rulers, and we're going to use meter sticks. So for those of you that get confused between meters and inches, or centimeters and inches, the smaller increments, the smaller lines, that's the side of the ruler that we want to use when we're doing scientific measurements. All right, question number 1. So this is going to take a little response. What would be the appropriate unit of length for measuring the following? All right, we want to use either kilometer, meter, or millimeter here. The thickness of your fingernail, the distance between your house and Highlands High School, and the height of the roof of your house. So those of you, let's, if your birthday, we'll do it this way. We'll do birthdays. If your birthday falls between January and June, go ahead and type your answers in the chat. So it should be the thickness of your fingernail, distance between your house and Highlands, and the height of the roof of your house.
Mr. Listener, what did you say for the names? A through F.
No, birthday.
Birthday.
January to June.
January to June birthdays. I like it.
Change it up a little. We good there, Mr. Ewald?
So we're starting to get some here. We have A, millimeter, B, kilometer, C, meter.
All
And then we
right.
have some other ones that are just doing like one at a time. So we have distance, kilometer, the nail, millimeter, the height of the house, meter. But it
Good
looks like
job,
for the
guys.
most part, spot on.
Awesome.
Awesome.
Good job.
Awesome, awesome, awesome. All right, if we were determining the length, here's question number 2. We're going to determine the length of the iPhone and the diameter of tape. So we're going to turn the camera around here. Mr. Wen's doing some measurement for us, and we're going to ask you to record on this.
Alrighty guys, so if we are looking at this ruler, we're looking at the larger numbers first, and those larger numbers are a representation of centimeters. What you're going to notice is that you also have these little tick marks as well. Those tick marks are going to be our millimeter. Okay, so here's what I want you to do. I want you to get as close as you can to what you think that length is. Okay, and if you know what the answer is, let's go ahead and put June to December. So those individuals whose birthday is from June to December, go ahead and put in those answers. Also, make sure to put this on a separate sheet of paper. So as we are answering these questions, make sure you have a separate sheet of paper out as well as something to write with.
All right. These guys are on it. So we have 15.5 centimeters, 15 centimeters, 15, 15, 15, 15.5 centimeters, 15. We got a 15.6, 15, 15.5. So it looks like mostly we have 15 centimeters, 15.5 centimeters, 15.6 centimeters. Oh, and we also have a 156 millimeter in there.
Nice.
I like it, already converting. Hey, one big thing to add in there, guys. Make sure you add those units.
Oh, yeah, we forgot to talk about naked numbers.
Yes. We don't like
Anytime you write a number down in science that doesn't have a unit, we refer to that as a naked number. And there are absolutely no naked numbers in science because naked numbers are inappropriate for school.
Alrighty, and so if you're wondering what that appropriate measurement would have been, Mr. Listman, what is that appropriate measurement?
I would say the appropriate measurement is 15.5 centimeters.
All right, good job, guys. For those individuals that had 15.5 or something close to that, good job. Now we're going to do the diameter of the tape. Okay, so let's go back to January to June. So those individuals whose birthdays are January to June, why don't you go ahead and put down the answer of what you think the diameter of that tape is.
No naked numbers. Make sure you put those units in there. All right, so we had one coming in, we had 10 centimeters, we had 10.75 centimeters, we have 11 centimeters, we have 10.7 centimeters, 10.8 centimeters, 10.5, 10.7, 10.7, 10.75. So we're right around that 10.5 to 11, somewhere in that range is where the majority of the students are falling. All of them have units on it now.
That's awesome.
Alrighty, guys. So the actual value of that diameter of the tape would be around 11 centimeters. Okay, so good job if you have around 11 centimeters. And now I'm going to throw it back to Mr. Listman.
Okay, as we were making our measurements, we had some people just rounded to the nearest centimeter. We had some people that gave us in centimeters with a decimal point. We had some people that went as far as 10.75 centimeters. So that gives us a great opportunity to talk about precision versus accuracy. And in science, we really want both. Precision is about how close our units are together. Okay? Accuracy is how close they are to the right answer. And I'm going to use a demonstration talking about Highlands here in a second to kind of emphasize that point. To say that Highlands is in Fort Thomas is an accurate statement. It is a true statement, but is it very precise? Not as precise as we could be, because it doesn't tell us where in Fort Thomas that Highlands is. If I said that Highlands is at 15 North Fort Thomas Avenue, that gives us a very precise answer, but it's not very accurate because it's the wrong address. What we want to be able to say is that not only is Highlands in Fort Thomas, Kentucky, but it is at 2400 Memorial Parkway. We want to be as precise and as accurate as we can be. Right? And it's a balance depending upon the measurement that you're taking and the values that you're looking for to decide where that margin of error is. Given what we did before, the most precise answers, the one that said 10.75 was the most precise because we could go down to the space between the millimeters and actually count that, yes, in fact, it was between 10.7 and 10.8 centimeters. If you left it at 10 centimeters for the diameter of the tape, that's fine, and that would be accurate, but it wouldn't be as precise as we would like. So we want to keep that in mind as we're taking our measurements. All right, let's talk a little bit about mass. It's the amount of matter in an object. And I like to ask Mr. Ewald this on a yearly basis. Mr. Ewald, do you matter?
100% I matter.
Absolutely, everybody at Highlands matters. Not just because your mother loves you, but because you have matter and take up space. So when you're in our classroom and you're taking up space and stealing our oxygen, you matter for us because you have mass. All right? So when we're talking about mass, we're going to talk about a golf ball. We'll talk about a ping pong ball. Both of them are about the same size. Obviously, a golf ball has more mass compared to the ping pong ball. And that's going to factor into a couple other physical properties. But at this point, we just want to identify that the golf ball, in fact, has more mass. Right? Our units for mass is the gram. Grams are very, very small units of mass. All right? It is about the size of a paperclip, or the mass of a paperclip is about 1 gram. The mass of an object will not change unless we add to it or take away from it. All right? Mass cannot change. Right? We will use a triple beam balance more often than not for our science classes. All right. Here are our units for mass: kilogram, gram, and milligram. We'll go question number 3. We want to know the amount of vitamin A in an energy bar, the mass of a bowling ball, and the mass of a mouse. Let's go if you were born on an even numbered day. Go ahead and put your answers in the chat here for those 3. Vitamin A in an energy bar, mass of a bowling ball, and the mass of our dearly beloved field mouse.
Nothing just yet, but they're going to start coming.
Mass of vitamin A in an energy bar. If you've ever read the label on any food product, you would know what that answer is.
All right, we have our first one coming in. The mass of the amount of vitamin A in an energy bar, milligram. The mass of a bowling ball, kilogram. The mass of our dearly beloved field mouse, gram. And then our next one, milligram, kilogram, gram. Milligram, kilogram, gram, milligram, kilogram, gram. Killing it.
All right.
All right, good job, guys.
All over our units, at least in terms of what would be most appropriate. So, this would be looking at a triple beam balance. This is how we would figure out the mass of a particular object. In this case, the middle bar is worth, the middle weight is worth a mass of 100 grams. All right. The upper bar here is factors of 10. And then the individual bar down here would be a single gram. So if we were to mass this thing, we would add up the 3 bars. Obviously, this one would be 0, so we're at 37.3 grams for this individual, whatever object we would be massing. Now, if it were to be that it was more than 100, we would slide the middle bar to the 100 and adjust the other 2 bars so that we could get the mass. All right, Mr. Wen's going to demonstrate for us here massing out the iPhone and the masking tape. We're going to turn the camera around here. All right, there is our iPhone. All right, and Mr. Wen's got our sliders.
Alrighty, guys. So we have our 3 sliders here. So here's our ones place, here's our hundreds place, and then here is our tens place. And so we want to make sure that we're accurate about this particular iPhone. So Mr. Listman, I'm sure you're going to give me some pointers on this. I'm just going to start moving it. Right? Is that what you're? Right? Is that?
We want to be a little more systematic than that, Mr. Wen. So let's put them all back to 0.
Okay. We're going to zero them out again. Okay. I'm sorry.
And actually, we should probably take the iPhone off of the scale first. And we want to make sure that our scale is zeroed out. And at this point, our scale is not. So we want to balance it out there. We may have to make a small adjustment there, Mr. Wen. Can we tighten that up toward the far end? We got it. There we go. Now we're zeroed it out. We can go ahead and put our phone on there. All right, we always start with the largest increments first, so we're going to move the 100 gram first. We'll move it 1 spot, 2 spots, 300 is too much, so we'll go back to 200.
Okay, now the important thing, guys, is that what you're going to notice is there's a slot inside that. So you want to make sure that you don't just leave it right in the middle. Okay, you got to put it in the slot so that you want to make sure that it stays there. Now we're going to go to our 10 spot. And we're just going to keep moving this until it goes down again. Okay, so that one went down. So we got to move it back just one more. Okay, and another one. Oh, there we go. Okay, so now it's going to go back up, and then we're going to go to our ones. We're going to keep moving it until we start to see it move. Okay, didn't move. Okay, so what did we do wrong? So we got to go back to the 10s, move it. Okay, so that was really close. So now we got to make sure that this line here is balanced with this line here. So we can see it's a little bit off, but that's about as accurate as we can get.
So our mass of our iPhone would then be, we are 200 on the middle bar, 50 on the furthest bar, and at 0 on the grams. So we're looking at 250 grams for the mass of our iPhone.
All right, now we want to make sure that you know how to read a triple beam balance. So we're going to try out the next one. So this is a piece of tape here. Now before you do anything, you want to make sure that you zero it again. Okay, so all the zeros there. We're going to place our tape down, and we're going to start right in the middle again. Okay, make sure that, okay, that one went down. So we got to move it back. We're moving it. Okay, so it's that number, and then we're going to move it until it goes down again. And we want you guys to tell us what this number is going to be. Okay? So once we get this zeroed out, or once we get this balanced at 0, we're going to show you guys what those numbers are. All right, so in the chat, why don't you guys go ahead and tell us what the amount of mass is on that triple beam balance, okay? So if your birthday is on an odd day, go ahead and put in your answers.
We got our first one in there. 95.4 grams, 95.4 grams, 95.4, 95.4, 95.4. Great job, guys. Awesome.
Fantastic job with measuring the mass. Let's talk about volume! Not that kind of volume, the other kind of volume. We get excited here in science. Let's talk about the amount of space that something takes up. All right? Obviously, from geometry class, you guys have dealt with volume before. Length times width times height. But what happens if we don't have a regular object or if we're dealing with a liquid? So obviously, cube solids, that makes things nice. Most of the time in biology, we are dealing with cube solids. No, we do not live in Minecraft world. Thank you. Right? Our units here would actually be cubic centimeters. All right, that's because it's centimeters times centimeters times centimeters, which gives us centimeters cubed. All right, but if we're dealing with liquids, we're going to use the liter. All right? We measure volume with a graduated cylinder. Mr. Wen, how do you know it's a graduated cylinder?
Because it has the lines on the side.
See, Mr. Wen doesn't get my humor.
Probably has a diploma or something like that.
Because it's been educated. That's how you know it graduated. No, the line's on the side. Love my dad jokes. You can comment later. Right? So we got two graduated cylinders on the side. They basically work the same way. Now, one of the things that we have to be careful of when we're measuring liquids is that liquids actually stick to the sides of the container and they create this curve in the tube. Right? That curve is known as a meniscus. When we measure a liquid, we always measure at the bottom of that curve or the bottom of the meniscus. So especially when you get into like taking medicines or you're measuring out dosages or you want to be very precise in what you're doing, you want to be very careful and make sure that you're looking eye level at that meniscus as you're making your and recording your measurements. We always read the bottom of our meniscus. All right, so in this particular case, here is our graduated cylinder. You can see that we've got a curve of our liquid, and it's slightly higher on the edges than it is in the middle. And if we were to go ahead and take a recording of that volume, all right, we would be looking at 43 mLs. Okay, because we're going to measure that thing from the bottom of that meniscus. All right. We're going to take a look at three actual graduated cylinders, and we're going to ask you to record the volumes, and we'll go just with Mr. Listerman's class on this one. All right. And we'll save it for Mr. Wen's class to do the other one. We're going to take a look at three different cylinders.
All right, Mr. Ewald here. I'm going to take you over here to our little setup so we can check out these graduated cylinders. So we're going to be looking at three of them. All right, the skinny one right here, this is graduated cylinder number 1. This one right here, graduated cylinder number 2. And over here we have graduated cylinder number 3. Now I know that it's not perfect, and it can actually be a little bit difficult to see, but we're going with Mr. Listerman's class. Okay, let's see if I can put this kind of right here in the middle. If you could, what would be your estimate on the volume of the liquid in graduated cylinder 1, the skinny one, and then graduated cylinder 2, which is right over there on the right-hand side? So go ahead and put in the live chat there. What do you think an estimate for the volumes would be for those two graduated cylinders? Mr. Listerman's class, do your thing. Obviously, if you were looking at this with your own eyes, it would probably be a little bit easier. But we're doing the best that we can here with our camera. So what do you think? Graduated cylinder 1 and graduated cylinder 2. All right. So
Alrighty, we're starting to get some answers in. Number 1, 6.5 mLs, 6.5 mLs, 6.7 mLs, 6.5, 6.6, 6.5. So we're definitely looking at that 6.5 to 6.7 range.
Absolutely. So here's graduated cylinder 2 again. And while you guys are putting those answers in there, I'm going to come over here to graduated cylinder number 3. Why don't Mr. Listerman students, why don't you guys do the same thing there? What do you think the estimate would be for the volume of graduated cylinder number 3, which is right there in the middle of your screen? What do you think?
Key stuff. I give it to you, sir. That's what you spray your desk down with.
All right, what do we think? Our 3 graduated cylinders.
All right, so for that second cylinder, we're seeing 17 and a half, 17, 17.2. And then for the third cylinder, we're starting to see 47, 47, 47.2, 46 and a half, 46.
All right. Pretty much spot on. I would say from where I am, and I'm eye level with these cylinders, I would say that the first graduated cylinder, we're looking at 6.5 milliliters. Our second graduated cylinder, we are in fact looking at 17 milliliters. And for our last graduated cylinder, we're looking at 46, even 46.5 milliliters. So you guys were right on again with those.
Awesome.
Great job.
Great job with that. So we've done length, we've done mass, we've done volume today. Little fun fact that in the SI system, they actually set this up in a really convenient fashion, that they define that 1 centimeter cubed of water is equal to 1 milliliter. And that 1 milliliter of water will have a mass of 1 gram. So it allows us within this system to convert between volumes and masses. The English system that we use doesn't allow us to do that. But fortunately for us, we can do this, and you can actually use water displacement to figure out the mass of objects and the volume of irregularly shaped objects. That 1 centimeter cubed equals 1 ml of water, which is equal to 1 gram. And we can use that conversion a lot in science, although we don't do it a whole lot in biology. All right, so here's our basic metric units. For length, we use the meter. For mass, we use gram. For volume, we use liter. Temperature, we use Celsius or Kelvin. And in time, we use seconds. Right? We're going to briefly talk about temperature here and why we have those two scales. For reference, in the Celsius scale, 0 is ice, 10 is chilly, 20 is nice, and 30 is hot. So we've got, if we were doing our temperature today, we would probably be somewhere about 27, 28 degrees Celsius. The Celsius scale is set up so that 0 is freezing. All right, it's also known as the centigrade scale, and that at 100 degrees Celsius, water boils. Those of you that are basketball fans, you know all about 212 degrees Fahrenheit, so you won't have to worry about what temperature Fahrenheit water boils. That's at 212. Freezes at 32 degrees Fahrenheit. But for our purposes, we're going to use 0 and 100. The Kelvin scale was created for mathematical purposes. In the Kelvin scale, it's impossible to have a negative number. They set their 0 at absolute 0, which is the coldest temperature that you can achieve. Therefore, all of their numbers are positive. Now, the good news for them is that the Kelvin scale still works on 100-degree separation. So their temperature where water freezes is actually 273 degrees, and it boils at 373 Kelvin. Again, that's something that's probably going to show its face much more in chemistry than it will for bio. But you need to be aware that there is actually a scale called the Kelvin scale. All right, so if we want to do some conversions, all right, how do we get from centimeters to meters, millimeters to meters? How do we do that? We can do it a couple different ways. The easiest way is simply moving the decimal point. All right, here's our scale: kilo, hecta, deca, our base unit, gram, liter, meter, deci, centi, and milli. To go from centimeters to meters, all right, we're centimeters here, millimeters are there in the middle. We're going to move 2 steps to the left, so we're going to move the decimal point 2 places to the left. All right. If you are in Mr. Wynn's class, go ahead and let's try a couple of these and post them in the chat. If you're Mr. Listerman's class, put them on your sheet of paper.
It can be a little hard to read the blue numbers. So
Okay.
it might help to use like a black
Yes,
yeah, so maybe outline those real quick. That makes it a little easier to see.
422 cm here. 69.63, and this would be liters. 9.23 grams, 6,523 millimeters on this side, 13 deciliters, and 230 milligrams.
So if you're in Mr. Wynn's class, why don't you give it a go and see if you can convert a few of those from the darker colored number to the blank. So centimeter to meter, liter to milliliter, gram to kilogram.
And as a general help, if the unit gets bigger, the number should get smaller. So if I'm going from centimeters to meters, the unit is bigger, so my number should actually get smaller. And my answer here should be 4.22.
Alrighty, so we have a couple people with 4.42, 4.42, 4.42. Alrighty, so good job, guys, on the 4.42. Well, sorry, 4.22.
So we got the right answers.
Yeah.
All right. On the second one, 69.63 milliliters, our numbers should get bigger because our units are getting smaller. We should have 69,630. So we move 3 places to the right. For the third one, we had 9.23 grams. So we're here in the middle, we're going to kilograms. We're going to move 3 places to the left. So we got to put some zeros in there, and our answer is 0.00923. For the top one on the second column, we're going from millimeters to meters. So our units get bigger, so our numbers should get smaller. 6.523 meters. 13 deciliters to milliliters. That's a fun one just because nobody ever uses a deciliter. Should be 130,000. And the last one, 230 milligrams to grams. We're going to move it to the left 3 places. 0.230 grams. Okay. If you struggled with this, we're going to have some practice both on all of our assignments and in our one-on-ones that we will have on Friday. So if you're struggling with this, feel free to reach out to Mr. Wen or myself, and we'll get you squared away. We don't want you to have too much trouble making these conversions. Blank slide there.
That was just for
All right. This is a fun question.
behind you on the whiteboard. It's like a
This one?
Yep.
Okay. I want to make sure that I was using the right thing. What happens if we don't have units of 10 to make that simple move the decimal point? Well, it makes sense to do something that we're all familiar with, converting money. Okay? So Vinny emptied his piggy bank. He had 22 quarters, 7 dimes, 9 nickels, 75 pennies. How much money does he have in dollars? If you were born on a day that ends in Y, I want you to answer that question. Put that in the chat.
What do you think? How much money does Vinny have?
How much money does Vinny have? Well, I have to make a conversion. I've got to make some changes. So what I would do is not only would I change I would have to change the units. So I know that I have 22 quarters. I use what's called the factored label method. Oh, the next slide is it? $1 has 4 quarters because that's what we're changing to. I always put changing to on the top, 4 quarters on the bottom. This is a fraction bar, so we're going to divide. 22 divided by 4 gives me $5.50. And we're going to be reminded later of this. Thank you, Mr. Wynn. You got a lot of stuff open now. Here we go. Sorry about that. 7 dimes, we would use the conversion. $1 has 10 dimes in it because we're converting $2 from dimes. 7 divided by 10 gives us $0.7. 9 nickels, the conversion is $1 is equal to 20 nickels. 9 divided by 20 gives us $0.45. Pennies, $1 has 100 pennies in it, so we would divide by 100. So we've got 0.75, so we add all of those things up.
Doesn't give you a total, you just have to do it.
Oh, I got to do this part. Now I got to do the work, huh? So let's
So-
see, 6.2.
Mr. Listman?
Yes.
So we have already, the student's going to work for you. So we've got a bunch of results for $7.40. So Vinny is super duper rich.
Thank God he's got a big piggy bank. All right. If you have any other questions or you're not sure about doing it, we'll do some of the factor label method when we get together in our small groups. We'll do some of these conversions as well at practicing on our own. You can type your questions in the chat here. Make sure that you check Schoology for instructions on how to submit your individual work. Check whether your teacher has assigned anything additional. We will have a small groups. My class will have small group meeting on Friday, and I will assign those groups later this afternoon. And Mr. Wynn, your small groups will be meeting Friday as well.
Yeah.
Okay. Thank you, Mr. Wynn. Thank you, Mr. Ewald.
Yeah, buddy.
Thank you all for participating today. Have a great rest of your Wednesday.
Give it just a minute to catch up, and then we'll.
How many do we have on there?